Hi there, let's look at this charger I've built. Essentially what I've got is a metal box with a earth metal box with a power supply on the inside. It's a 5-volt power supply at greater than 5 amps. I've connected it onto this board at the side here using these two wires. The board at the side is just a piece of copper clad circuit board onto which I have fastened these types of connector, which are a USB connector. Not this particular type because that's too difficult with the metal end on, but this type here where this is surface mounted and the wires are easy to get at, or at least the leads are easy to get to and to lift up and to solder onto them. The two I want are the two outside ones and the two in the middle of the data, so I'm not particularly bothered about those. Having soldered them on, bend up like these have been bent up so that they is soldered on. Bend out the wires, solder them together, and then I've got switches on as well. And what I can do is to plug in these capacity meters to measure the amount of milliamp hours that have passed through them. Not particularly accurate, but well, good enough for what I want, I think. If we switch them on, then what we see is we have got, when they settle down, about 5 volts coming through each one, which looks quite good. That one's at 4.97, that's 3/100ths of a volt less. Quite good really, not that much difference. Pretty good for what I want. I can then charge my usual sorts of things. Let's try with a charger device, oh dear, power bank, isn't it? It's a power bank. It's got two connections on the end, one for charging and one for the output. I can thus connect this into one of the things, getting it the right way round, and charge it in. Get that the right way round. Have to switch it on, and it tells me it's taking something like 230 milliamps charging this particular device. On these meters then, what we have here is the voltage. Here we have the time it's been on for. Oops, it's gone off. Here we've got the charge that's going into it, and here we've got the milliamp hours that we put into it. So this seems to think it's already put 1 milliamp hour into this charger. Why bother with this particular gizmo? Well, I want to know what's happening inside, or well, what's happening when I'm charging things. I don't just want to plug in and hope for the best. That's okay, of course, if you've got a 5-volt 1-amp charger. You can just plug the lead straight into that and straight into the gizmo, and that then would charge it up. So why do I have gone to this? Well, 5 of these would be quite a large amount of space. This reduces the amount of space and it enables me to have these quite close. I've taken the cases off so they can get even closer together. These have got a button on the top, so they have a memory, so they remember here, for example, I've got my 1 milliamp hour. Up at the top here I've got 425 milliamp hours on the last gizmo I charged, and it took 48 minutes to do it. So if I press the button at the top for 5 seconds, then hey presto, it goes back and it zeroes it, so we can see how many milliamp hours has gone into whatever we're charging. Don't rely too much on this, because very often when we're charging something it will have a partial charge to start with, but at least it lets us know how far it's gone. So why would I want to use all these meters on it? Why not just use one of these gizmos, which is a charger which can charge 4 cells. It just has a USB connector on the end. Why not just use that? Well, chargers don't know which each cell is getting, so it may be that each cell is corrupt or one of the cells is corrupt, so I need to know what the actual current to each cell is. Unfortunately on this it just has 4 chips, unmarked chips, and LEDs for each particular one. The power comes in then, but comes down here. Unfortunately it breaks up the power, the positive, to each chip. So what I could do is just cut across here, solder onto each of those wires, and then I could put my meters onto those. It's a nice little gizmo this, but not exactly what I am looking for. So here we have it then. This is my charger device. I can plug in leads that have either the USB on the end, or I've modified leads so that what? Oh, come on. So that I can connect my devices straight on to the thing. Unfortunately my devices aren't very good because I've decided to use 2 pins, which is a historic thing. I've done it for years, but should have put it so that it can be it can't go in the wrong way round, which this of course can. So if I plug this in, it can go in either way round, that way or that way. And because of the way I'm using them, I can't put diodes on them to protect the direction. So yeah, a handed plug would have been a lot better, but I ain't done it, so I'm stuck with this system. What do I want to look at? Well, let's have a look at, for example, some of the boards that give me reason for concern. If I look here, plug this in, then I have some boards, hopefully I can find them, which cause me concern. Number 14, for example, if I take that and I connect it, the red light comes on straight away, even though it's not charging anything. The red light usually means that it's charging, and if I try to charge a cell with it, it doesn't actually charge. So that's obviously a faulty board, which needed looking at. Another sort of problem is, if I can find it, this number 13 board, which if I plug that in, I immediately look here, it's not connecting anything, no LEDs lighting, but it's actually taking something like half an amp. So where that half amp is going on that board, I have no idea, but something's going to get hot, and not that interested in trying to find out what. We have other boards then. One of the problems with these boards is quite simply that the sockets are surface mounted, and because they're surface mounted, if we look here, the socket itself has actually broken off. This board wasn't too careful with it and it broke off. Another thing with these boards is that we can change the resistor on them. They're supposed to charge at 1 amp, although I find them very rarely charging at 1 amp. But what we can do is to remove a resistor. Have I done it on this one? Yep. So this resistor down at the bottom, where there, don't know if I can try this, let's try, yep, I've put a 103 resistor on there to reduce the charging current, because of course with small cells you don't want to be putting too much current into it. So by replacing that, I can work out what current's going in by putting in my 10k resistor. So yeah, that's basically why I have set this system up. I can of course have my cells in any sort of holder. Doesn't have to be a special holder. This is just one with paper clips at the end to hold the cell. And here's another that I've designed. Well, it's just a simple thing. It's just a nut on the end with this rod going through, so that I'm able to charge cells that I want to. So yeah, that's my charging gizmo. It's more compact, I think, than the 4 or 5 mains chargers, and it seems to work quite well for me. So I wouldn't bother trying to charge cells without knowing what the current is and what the voltage is. Sometimes you plug one of these boards in and the voltage goes zoom right down, because it's more or less a short circuit. So yeah, safety first all the time, I think. Got to be careful and make sure that we are safe. So it's bye now. Bye.